In this tutorial, we are going to learn about product rule. And product rule is a method we use when differentiating the product of two separate functions. Let us see an example. In this case, y is a product of two separate functions. We have the linear function 5x, and we have a cubic function of 2x plus 1 into bracket raised to the power of 3. To be able to use the product rule, we need to first of all focus on the formula itself, and then we see how we can use it in finding the derivative of y. The product rule formula states that change in u multiplied by v due to change in x is equals to the function u multiply by dv dx, then you add the function v multiplied by du over dx. As you can see from this formula, we need to identify the u and the v from the function. Then after identifying the u and v, we find dv dx and du dx. So let us do that. In the function given, the u is normally the first function of your composite function of y. So in this case, as you can see here, 5x is the first function and 2x plus 1 into bracket raised to power 3 is the second function. So you're going to say let u be the first function, which is going to be 5x, and v is going to be the second function, which is 2x plus 1. You close the brackets, then you raise it to the power of 3. The second step, we need to find change in u due to change in x, and in this case, we are going to differentiate the u function. When you differentiate 5x, you'll get a derivative of 5. Then we look for dv due to change in x. The v function is a composite function. In this case, a composite function, we differentiate it using the chain rule. To learn more about the chain rule, you can follow the link above or the link in the description box below. Let us find the derivative of v using the chain rule. The answer will be 6 into bracket 2x plus 1. You raise it to the power of 2. Now that we have the u, the v, the du dx, and dv dx, we can substitute them in this formula to find the derivative of y, which is change in y due to change in x will be equal to, we take these variables, we substitute to this formula. In this case, since we have the u as 5x, so we'll have 5x, you multiply by dv dx. dv dx is this derivative here, that is 6 into bracket 2x plus 1, close the brackets, you raise it to the power of 2. Plus, we take the v is this function here, that is into bracket 2x plus 1, you raise it to the power of 3, then you multiply by du dx. du dx is the derivative 5, and from here, we just need to simplify our function. So the simplified form, you're going to get change in y due to change in x is equals to, when you multiply this, gives you 30x into bracket, then the function 2x plus 1, you raise to the power of 2, plus when you multiply this, you get 5 into bracket 2x plus 1, you raise it to the power of 3. And this is the derivative of our function y. Let's look at another example. You are told differentiate the following function. And as you can see, y is a function of a product of two functions, which means we can use the product rule to differentiate our y. To do this differentiation, I write the product rule formula first. That is, change in u multiplied by v due to change in x will be equal to u multiplied by dv dx plus v multiplied by du dx. So we need to identify the u, the v, so that we find the dv dx and du dx. So let us do that. From here, as we said, the first function of the composite function is normally the u. So you're going to say let u equals 2x plus 3. And obviously v is going to be equal to 4x squared minus 2. Then you raise it to the power of 5. The next thing we will do is find du dx and dv dx. And let us start with du dx. Du dx is the derivative of u, and the derivative of u in this case is going to be a 2. Then we'll find change in v due to change in x, and we're going to differentiate the v function. And the derivative of the v function, we're going to use the chain rule to differentiate that, and that is going to give us 40x into bracket 4x squared minus a 2 raised to the power of 4. Now that we have these variables, we can substitute them to the product rule to find the derivative of y. That is, change in y due to change in x is going to be equal to, you take the u, in this case the u is 2x plus a 3, you multiply by dv dx. dv dx is 40x into bracket 4x squared minus 2, you raise it to the power of 4, plus you take the v is 4x squared minus 2 into bracket, you raise it to the power of 5, you multiply by du dx, and du dx is a 2. From here is just simplification, that is change in y due to change in x is equals to 40x into bracket 2x plus 3 into bracket multiplied by 4x squared minus 2 to the power of 4 plus 2 into bracket 4x squared minus 2 raised to the power of 5. And this is the derivative of our function y. We have that example, and we are told find dy dx of the following function, and dy dx of a function is just finding the derivative of that function. And as we can see here, our function y is a product of two functions, that is 5x squared multiplied by the exponent raised to the power of 2x. In this case, we are going to use the product rule formula, change in u multiplied by v over change in x, which is equals to u multiplied by dv over dx plus v multiplied by du over dx to find the derivative of our function. So we'll identify the u and the v, that is, let u equals the first part of that function, which is 5x squared, and the v, which is equals the exponent of 2x. Now from here we need to find change in u due to change in x, and when you differentiate the u, you're going to get 10x. Then we'll have to find change in v due to change in x, and in this case we are going to find the derivative of the v function. And the v function is an exponent function. To differentiate the exponent function, we just differentiate this part, that is going to be a 2. Then you multiply by the exponent function and return back the power of that exponent. To learn more about how to differentiate the exponent functions, you can follow the link above or the link in the description box below. After getting these variables, now we can substitute them in the product rule formula to get the derivative of y. Therefore, you get change in y due to change in x is equals to, you take the u is this one here, 5x squared, you multiply by dv dx, dv dx is 2 exponent 2x, plus you take the v function is exponent 2x, you multiply by the derivative of u, that is du dx, in this case is 10x. Now from here you just simplify, change in y due to change in x will be equal to, when you multiply this, you'll get 10x squared exponent of 2x, plus when you multiply this one, you're going to get 10x exponent of 2x, and this is the derivative of our function. That brings us to the end of today's discussion. Thank you for watching.